Hello everyone, welcome to today's video on graphing proportional relationships. So there's two key concepts we need to know coming into this. The first one is that the graphs of proportional relationships are straight lines through the origin. Additionally, the point 1k is going to represent the constant of proportionality and our unit rate. So that's a special fact about the constant of proportionality. It also represents our unit rate. Okay, so let's dive into our first question. Martin and Isabel go bowling. Each game costs $10 and they split that cost. Martin has his own bowling shoes, but Isabel pays $3 to rent shoes. Complete the graphs below. So we're going to graph the cost for Martin for bowling based on the number of games played and then that total cost. And then we're going to do the same thing for Isabel, how many games she played and how much money she's then paying for bowling. To do this, I'm going to start with trying to create a table of points. So let's start with Martin. Okay, Martin's going bowling. Each game costs $10, but Martin and Isabel split that cost. That it's a $10 fee, but it's split, so that means we're going to divide it. It's split into two, so that's $5. That's going to be important. That means that Isabel and Martin are both spending $5 per game. For each game they play, they're going to spend $5. Okay, and then let's see, Martin has his own bowling shoes, so that's Martin's only expense. Every game costs $5. Let's notice here that games played, this is on my x-axis, right? My horizontal axis, that's my x-axis. So all these values, well, 0, 1, 2, 3, 4, 5, those are x values. Okay, so if I have this x value of 0, so that means that Martin played 0 games. How much is Martin paying? Well, then it's going to cost him no money, right? So that would mean that he would have this y value also of 0. So next I have Martin played 1 game. Okay, so Martin plays 1 game, and we just figured out that Martin plays $5 per game. After 1 game, it's going to cost Martin $5 for us. So if we play 2 games, how much is that going to cost Martin? Well, it's $5 per game. So we're going to have $5 for the first game and $5 for the second game. 5 plus 5, or 5 times 2 is 10. Okay, so that's going to end up costing Martin $10. Okay, and then we'll quickly do one last one. If Martin's playing 3 games, that's going to end up costing him $15. Calculate y divided by x for each of these points. Now, we're actually not going to be able to calculate y divided by x for the point 0, 0. 0, 0 is a special point. It's the origin, and we need it on a proportional graph. We need the point 0, 0 to be there. But if you type in a calculator 0 divided by 0, it's going to say an error. Okay, you cannot divide a number by 0. It does not mathematically work. Okay, but we're not going to be able to get a value for that. But we can for all the other ones. And divide our y5 divided by 1. 5 divided by 1, what is that? 5. Okay, then I have 10 divided by 2 is equal to 5. And then I have 15 divided by 3. And that is also going to be equal to 5. Okay, so we have a consistent constant of proportionality, which is 5. Now, you might be saying, okay, Ms. Deliotis, we just did way too much work there because we already figured that out, $5 per game, right? And that's what we did here. We did 1 times 5, and that gave us 5. We did 2 times 5, and that gave us 10, and 3 times 5, because for every game we were spending $5. Okay, so for Martin's situation, we do have a proportional relationship. Let's graph these points. So our first point is this point 0, 0. The x value is 0 and the y value is 0. So I'm looking for my x value of 0, my y value of 0. That is the point 0, 0. We call that the origin. So I'm going to put a point right there. Then I have the point 1 and 5. So 1 game is played, that's costing $5. So I'm going to put a point right there where my x value is 1 and my y value is 5. Then I have 2 10. So I'm going to find 2 on my x, go up to 10 on my y. That point is 210. As we can see, this is going to keep happening. 4 games would cost $20. 5 games could cost $25. So we're going to connect the point. Okay, so I'm going to draw this line. There we go. And that's going to go on forever. Let's just start with question 5, then we'll go back to Isabel. Which graph shows a proportional relationship? So does Martin's graph now show a proportional relationship? Yes, we know that how much Martin is spending is a proportional relationship. There is a constant of proportionality, K. K is equal to 5 because we are paying $5 per game. That's how we figured it out from the table, but this is saying from the graph. So we have to go back to that key concept that we talked about earlier. Graphs of proportional relationships are straight lines through the origin. Okay, and if I look here, these points, they form a straight line, and they go through the origin, which is the point 0, 0. Martin's bowling cost graph shows a proportional relationship because it is a straight line that goes through the origin, which is the point 0, 0. So that's going to be my reason for why Martin's graph shows a proportional relationship. And we know it shows a proportional relationship because there is this proportional relationship between games played and cost. Alright, great job. So now we did Martin's. Now let's look at Isabel's. Like before, what we're going to do is we're going to try to come up with some points that we're eventually going to graph, and then we can use with a table to figure out if we have a proportional relationship. Okay, so we still have it, the cost per game for Isabel is going to be $5 because there's $10 per game and they're splitting that in half. But Isabel has this additional expense. Isabel pays $3 to rent shoes. So that means something special. When I go to bowling, I show up there. I haven't played any games yet, but the first thing I have to do is I have to buy shoes. When Isabel's played 0 games, it actually is costing her $3. That's going to end up changing our situation, as we'll continue to see. Okay, so then let's figure out if Isabel just plays 1 game. The cost of 1 game is $5. So she's paying $5 for the game, and she had to pay for shoes. So it's going to be $3 plus $5. It's going to cost her $8. All right, let's go to another one. 2 games played. So it's $5 per game. So if I play 2 games, it's going to be 5 plus 5. 5 plus 5 is 10. So I'm paying $10 for bowling. And then I have to pay $3 for my shoes. You only pay for shoes once, no matter how many games you play. So that's going to be $13. So this is going to come out to $18. Now, let's figure out, first using my table form, whether I have a proportional relationship. Again, I can't divide, when you divide by 0, that doesn't work. So we're going to ignore the first row. Okay, that's a special situation. But let's do it for the next 3. So I'm going to take 8. I'm going to divide by 1. Okay, for my second one, I'm going to have 13. And I divide by 2. So that's the cost for 2 games. And then lastly, I'm going to divide the $18 price I pay divided by the 3 games. And we need to see, are we getting equivalent ratios? Are those all equal to each other? So does Isabel have a proportional relationship between games played and cost? No, because there's not a constant of proportionality. When we find y divided by x, those ratios are not equivalent to each other. Because that $3 shoe is messing it up. We only play it 1 time. Okay, we cannot just multiply our x. We can't just multiply our x times one number to get y every time consistently. Okay, so Isabel's situation is not going to represent a proportional relationship. Now that we know that, let's look at the graph to see what that looks like. So for our first point for Isabel, we have that 0 games were played, and that cost is about $3, because again, she had to pay for those shoes. So that point's going to be somewhere around there. It's 0 on my x, and then it's 3 somewhere in between 0 and 5 for my y value. Okay, so then I have 1, 8, so it's going to be 1 on my x, and then somewhere in between 5 and 10, a little bit closer to 10, for my y value. So that's going to be this point right here. 1, 8. Okay, then I have 2, 13. So 2 is my x, 13 is going to be around here, in between 10 and 15. Let's see if those form a line. Yeah, it seems like that pretty nicely. Those form a line. That line does not go through the origin. It does not go through 0, 0. It goes through 0, 3 instead. Okay, so graphs of proportional relationships are lines. We have that quality, but they also must go through the origin. We're going to continue looking at this problem, just a few other questions. So question 6 says choose one point on the graph of the proportional relationship and explain what this point means in terms of the situation. Proportional graph, of course, is Martin's. So since we're overachievers, we're actually going to look at 2 points. So I'm going to first pick the point 315 right here. 315. 315 means we have the x value of 3 and this y value of 15. So the point 315 means that Martin pays $15 to play 3 games. Okay, where did I get that from? Well, I look at the x value, that 3 represents 3 games played, right? And then I look at my y value of 15, that represents my cost. So Martin's paying $15 to play 3 games. Okay, so now we're going to look at another point. I'm going to choose the point 1, 5 right there. So that point 1, 5 is pretty important. So the point 1, 5 means that Martin pays, well, what's my y value? $5 to play how many games of bowling? Well, my x value was 1, right? So that means to play 1 game of bowling. The reason I said this point is important, the point 1, k represents the unit rate and the constant of proportionality. K, of course, is my constant of proportionality. So we said for Martin that our constant of proportionality, y divided by x, was 5, right? Because we're playing $5 per game. So this point is telling me something special, right? 1, 5 means that the unit rate is $5 per game, and that the constant of proportionality is 5. Awesome. Okay, so then let's look at question 7 to wrap this up. So what equation represents the proportional relationship? So my equation is y equals 5 times x.